Hello, in this AV, we would be talking about the numericals of exercise 5C. So the first numerical says, a rubber ball floats on water with its 1/3 volume outside water. What is the density of rubber? So we will first find out what is the volume which is inside the water. So we'll assume that the total volume is V and we will substitute 1/3 of V from the total volume and we'll get the volume which is inside the water. So let's write the given things. So here we have written the given things. We have assumed that let the volume of the ball be capital V, and it's given that the volume which is above the surface of water is 1/3 of the total volume, that is 1/3 of the V. So the volume of ball which is immersed in water will be total volume minus the volume which is immersed, that is V minus 1/3 of V. So we get 2/3 of the volume which is which is immersed in the water. So by the principle of flotation, we have the volume of rubber ball immersed in water divided by the total volume of rubber ball will be equal to the density of the rubber divided by the density of water. So we have the volume of the rubber ball immersed in water, we have the total volume of the rubber ball, we have the density of water, we have to find out density of rubber. So we just put the values. Volume of rubber ball immersed in water is 2/3 V. So we write 2/3 V divided by total volume is V is equal to density of rubber divided by the density of water, that is 1000. So we have 2/3 is equal to density of rubber divided by 1000. So when you solve it, you will find the density of rubber, that is 2 into 1000 divided by 3. So after calculation, you will get the answer, that is 0.7 kg meter cube. So this is how we have to solve it. Now we go to the next question, that is number 2. It says a block of wood of mass 24 kg floats on water. The volume of wood is 0.032 meter cube. We have to find the volume of the block which is below the surface of water and the density of the wood. So we write the given things first. So here we have written the given things, that the mass of the block of wood is 24 kg. Now the volume of the wood is 0.032 meter cube. So we have to find the first part says find the volume of the block below the surface of the water. So we know the formula of upthrust, that is upthrust is equal to volume of the wood below the surface of water multiplied by density of liquid multiplied by acceleration due to gravity. Also, for flotation, the upthrust is equal to the weight of the body. Here I'll write. So for flotation, upthrust is equal to the weight of the body. So mass of the block is 24 kg. So weight will be 24 kg F. Now we put this value here in this formula. So upthrust will be 24 is equal to volume, we will just denote it by V. Density of the liquid, that is density of the water, is 1000 multiplied by the acceleration due to gravity. Let's leave it as G because here we have made some changes. Now V will be equal to, the volume is equal to 24 divided by 1000. So that will be equal to 0.24 meter cube. This is the volume of the block which is below the surface of water. and the next part of the question says the density of the wood. So again we will write that law of flotation here. So here we have written the law of flotation. Volume of the submerged block divided by the total volume of the block is equal to density of the wood divided by the density of the liquid, that is water. So we write density of water. Now volume of the submerged block we have calculated here, that is 0.24 divided by the volume of the total block is given here in the question. So that is 0.032. Density of wood we have to find out, so we just write it as it is. Density of wood divided by the density of water is given to be 1000. So from here we can calculate the density of wood, that is equal to 0.24 multiplied by 1000 divided by 0.032. So after calculation it should be 750 kg per meter cube. So if you know the law of flotation, half of the problems of this exercise will be solved as I told you in the class. Please revise this portion before you do the numericals, and then it will be easier for you to go ahead. Now we go to the next type, that is question number 4. It says that a piece of wax floats on brine. Brine is basically a salt solution. What fraction of its volume is immersed? So we have to find the volume which is immersed in the liquid, volume of the wax which is immersed in the liquid. So of course we will be using the law of flotation again. So let's write the given things. So here we have written the given things, that the density of the wax we have denoted it as rho W is equal to 0.95 gram per centimeter cube, which is given in the question. Here you can see the textbook also it's given, and the density of the brine we have denoted it as rho B is 1.1 gram per centimeter cube. So we have assumed that the total volume of the wax B, capital V, and the volume of the wax which is immersed in the liquid or the brine is denoted as small v. So according to law of flotation, the volume of the submerged part divided by the total volume is equal to density of the wax divided by the density of the liquid, that is brine. So we have the value for these two, the densities. So we just write the volume of the submerged part will be the value of this ratio, that is the ratio of the density into the total volume. So the density of the wax is 0.95 and the density of the brine is 1.1 multiplied by capital V, that is the total volume. So after this comes out to be the volume of the submerged part is equal to 0.86 of the total volume. So you can just write here that the wax floats with 0.86th part of its volume above the surface of the brine solution. So 0.86th part of the total volume is immersed in brine. Now we go to the next type of the question, that is number 6. It says a piece of wood of a uniform cross section and height 15 cm floats vertically with its height 10 cm in water and 12 cm in spirit. We have to find the density of the wood and the spirit. So let's write the given things. So here we have written the given things. Height of the wooden piece is total height, that is 15 cm. Height of the wooden piece which is immersed or submerged in water is 10 cm, and the height of the wooden piece which is submerged in spirit is 12 cm. We have assumed that let the density of the wood be rho wood gram per centimeter cube, and the density of the spirit is rho spirit gram per centimeter cube. These are the entities that we have to find out. So for the first one, we have written the law of flotation, that the volume of the wood which is immersed in water divided by the total volume is equal to density of the wood divided by density of the liquid. Here we are immersing the wood in water, so density of water. In the next part of this question, that is for spirit, everything will remain the same except this density of water will be replaced as density of the spirit. So let's put the values and calculate. We have the volume of the wooden piece, which is the part of the height of the wooden piece which is submerged in water, is 10 centimeter. So we write 10, total is 15, is equal to density of wood we have to find out upon density of water is 1 when we take it in gram per centimeter cube. So we solve it and we get the answer as density of the wood is equal to 0.666, it continues, so 67 gram per centimeter cube. For part 2 of this question, according to law of flotation, according to the law of flotation, we have the volume which is immersed in the spirit divided by the total volume is equal to density of the wood divided by density of the spirit or the liquid in which it will be immersed. So again, this volume which is immersed in the spirit is 12, the total remains the same, that is 15, is equal to raw wood, that is the density of the wood we have just calculated, 0.667 divided by density of the spirit. Please do the calculation. Then density of the spirit will be equal to 0.667 this comes here, 12 goes down, multiplied by 15 upon 12, so it should come to the answer given here in the book is 0.8333 gram per centimeter cube. So this is how we go about it. Now another type of the question is number 8. The density of ice is this, that is 0.92 gram per centimeter cube, and that of seawater is 1.025 gram per centimeter cube. We have to find the total volume of an iceberg which floats with its volume 800 centimeter cube above water. So we have to find the volume of the iceberg which is below the water or which is immersed in the sea. So let's write the given things first. So here we have written that let capital V be the volume of the iceberg, and the volume of the iceberg above water is already given in the question, that is 800 centimeter cube. Volume of the iceberg which is submerged in water is the quantity that we have to find out, so we have assumed it to be small v. Density of ice denoted as rho ice is 0.92 gram per centimeter cube, and density of seawater, rho seawater, is 1.025 gram per centimeter cube. This is given in the question. So according to law of flotation, the volume of iceberg which is submerged in water divided by the total volume of the iceberg will be equal to the density of the ice divided by the density of seawater. Now we do not have these two values, so we write the values that we have, that is the value V is equal to this, we are multiplying the total volume, we are multiplying it on the right hand side. So rho ice is 0.92 divided by the density of seawater is 1.025 multiplied by the total volume. So this comes out to be, after division, 0.8976 of the total volume. So the volume which is submerged is this part of the total volume. So we write here, volume of the iceberg above water is total volume minus the volume which is inside water or which is submerged in water. So volume of the iceberg which is above water is given in the question, that is 800 centimeter cube, and here we can take V common, so we will be left out 1 minus 0.8976. so the total volume is 800 divided by 1 minus 0.8976. so after calculation this will come out to be as 7812.5 centimeter cube. So that's all in this EV. Thank you. God bless.